Sorry. Okay. All right. For those who just joined the Zoom, please take note on the nearport link for today. Not this one. Sorry. All right. So we shall begin. All right. For today's session, right, we're going to talk about uh acids and base. So what is acid and base? These two giants always interact with each other during our chemistry lessons when you're in schools. So from our bodies to our earth, ocean, and rocks, acids and base plays play an important role in our lives and the environments around us. If you have taste lemon juice or wash your hands with soap, you are actually experiencing acid and base. Well, scientists in the world basically classify substances as acid, base, or neutral, depending on the characteristics of taste or pH value. One example is, right, for acid, we know that acid tastes sour. So that's why I mentioned that if you drink lemon juice, you are actually interacting with acids. Whereas for base, it's more towards slippery. The texture is a bit slippery to touch. So majority of the substance that we know to clean ourselves or all those cleaning products, they are all base. That's why I mentioned just now that in our life now, we are unable to live without acid and base. So for today's lesson, we are going to go through, right, to find out more, right, how acid and base actually impact our environment, and also ask ourselves, right, in our daily life, how which substance is acid, which substance is base. So the chapter is exploring acids and base. So some essential question that maybe you have to ask yourself: how can we better understand substances in our daily lives by relating them to acid and base? Just like just now I mentioned about lemon juice is sour, so that's why it's acid. Cleaning product detergent is base. So let's carry on directly. So students, for those who have just joined in the Zoom chat, I want to see a show of hands through the nearport. How much you already know about acid and base? Do you know a lot, or do you know a little, or you do not know anything? This will allow me to plan my lesson later, whereby I will see how should I structure my words or do some class activities. So do share with me your answers. So how much you already know about acids and base? Just now, Teacher Andrew mentioned about lemon juice, mentioned about detergents, mentioned about the pH values. So tell me, how much have you know? All right, I see that majority of the students here know a little bit about acid and base. Whereas we have some students who are not sure, don't know anything. Not to worry. Let's learn together today. All right, let's carry on. So now, in the next slides, you'll be exploring in your own devices a coral leaf. As you look at this coral, think about factors that can harm them. All right, so let's start now. So in this particular picture, you can see this coral here. As you mentioned just now, acid and base interact with the environment almost every single day, every single second. Think about, as you look at this coral, what are some of the factors can actually damage them or harm them? All right, I'll give you some time to look around this coral. You can see sharks. Well, that's not important. Look at the coral here. What are some of the things that you feel that it can damage them? All right. Another 20 more seconds. I shall carry on afterwards. All right, let's carry on. So the question for you to answer is, what is one way that humans can impact the coral? What is one way that a human can impact a coral reef? Reef, yes. So please type your answers and let me know once you are done. What are some ways that you think that we do that can impact the coral? Cut it, okay, yes, we cut it. Some of them cut samples. When you cut them, you hurt them, correct? Cut, all right. What else? Well, actually, the scientific answer is pollution. Pollution, overfishing, or destructive fishing practices. Yes, Lam, well done. Can impact the coral reef. Why do I say so? So pollutions, overfishing, destructive physical damages, all these things can affect them. Well done. Very good. So let's carry on now to the next section. Just now, the image you saw is a live coral reef, all right? This little coral reef is a living thing. It can die when the acid level of the ocean becomes too low. In today's lesson, we are going to look at the characteristic of acid and bases and how they affect the world we live in. So when there's not much acid, the acid level in the ocean is too low, the coral died. All right, this is something that can be we human, our substances, our rubbish can basically impact the coral reef. All right. So let's look at it in proper details. So now on the following slide shows, we will start to learn about the characteristic of the acid, base, and as well as their characteristic. All right, let's carry on. Okay, number one, the characteristic of acids. All right, students, acids. As long as you see the word acids here, all their chemical symbol or formula contains hydrogen, which is H here. All right. So we have hydrochloric acids, sulfuric acids, and phosphorus acids. All right. So chemical compounds that are considered to be acid are made up of hydrogen ion, H plus. If you see a H there in the equation, this means to say that this particular substance or chemical is acid. All right. The name of the acid always ends with the word acid, whereas the base word will either end with IC or OUS. This is some of the ways to differentiate between acid and base. All right, let's carry on. characteristic of bases are made up of hydroxide, OH symbol, and the base of the name always ends with hydroxide. When you see the word acid and a name like a hydrochloric acid, HCl, it is telling you that it is acid. When you see the word hydroxide and in the name of the chemical, this tells you that it is a base. So we have sodium hydroxide, magnesium hydroxide, and aluminum hydroxide. These are some of the ways that we differentiate between an acid and a base. All right. One acid have hydrogen, ends with acid. The chemical symbol always have a H inside. For base, the name will always end with hydroxide. Chemical symbol OH. Some example is sodium hydroxide, NaOH. All right, let's carry on. Acid and base, how does scientists use to see whether this particular liquid or substance is acid or base? They use this thing called the pH scale. Acid is a range from 0 to 6.9. And then for base is 7.1 all the way to 14. In a layman term, basically 0 to 6 is acid. 8 to 14 is base, or known as alkaline. All right. Another word for base is alkaline. 7. Why 7 is not base acid or base? Because 7 is neutral. The only substance that is neutral at your level is water. So if you are drinking water, you are drinking a neutral substance. We have the pH value of 7. If we look at this pH scale table, we know that batteries is the most acidic substance, followed by our stomach acids that used to digest the food. Then we have lemon, number 2, vinegar at level 3, tomatoes at level 4, coffee at level 5, milk at level 6, 7 is water, 8 is blood, baking soda is 9, stomach tablet is 10, then we have ammonia solution 11, soap is 12, bleach is 13, and last but not least, drain cleaner is number 14. So all this is good for you to know. So I'll send you the student link shortly after the lesson for you all to learn at your own timing. Just make sure that for this chapter, just need to make sure that you memorize some of the substance. What are the 3 types of acid? What are 3 types of alkaline or base? You will basically master the basic of this chapter. All right. Let's carry on. One way to test if the substance is acidic or base, the main thing is to test using a pH paper. The paper will change the color depending on the pH value of the substance. So once you got a paper, you will take a paper and compare the color that is reflected here, 1 to 14. All right. So from here, if the color is blue, you'll know that it is basically number 12. So on and so forth. All right. So let's carry on. I have some activity for the class to do. All right. In these activities, look at your nearport now. We have the following substance called pH7, turns litmus paper green, calcium hydroxide, H2S, pH 13, water, turn paper into purple, OH, pH 2, coffee, hydrobromic acids, bleach. You have to drag and drop the words acid, base, or neutral in the comment below. For example, pH 7. pH 7 is actually neutral. So I drag here, I put neutral. All right. There we have turn the litmus paper rate, so on and so forth. All right. So students, now please do your answer now. I'll give you all 5 minutes to do this question and we'll go through the answer together. All right. Your time starts now. All right. Look at the table. Just now we went through the pH scale. 0 to 6 is acid, 8 to 14 is alkaline or base, 7 is neutral. So from there, you should roughly know what is the pH value. So I give you 5 minutes to do it. Once you are done, we will go through together. All right. So which one turns the pH litmus paper rate? Is it acid? Is it base or neutral? Well, take your time. Okay, this person. Okay, we have this person who is doing very currently. Yes, pH 7 is neutral. Well done. Turn litmus paper rate is acid. Correct. All right. Let's look at other people now. We have Supreme. Neutral, acid, base, neutral. Well done. So far, so good. Let's look at other people now. Well, we have currently 13 students in the class. So let's see whether you can get the answer. All right. So the drag and drop the difference page label acid, base, or neutral into the respective column, row. And from there, once you are done, we'll go through together later. All right. Remember, acid have two features that you know is acid. The chemical symbol contains H because it's hydrogen ion. The pH value is less than 7. The name itself has acid in it. And it will turn the paper rate. All right. As for base, it's pH 8 to 14. Have the chemical formulas or symbol OH. And it turns the paper towards purple. So with that, let me see your answer. You have 3 more minutes. Take your time. Don't rush. I can see that some people are still doing. All right, we have yes, Super, some answer already. Later we'll go through. Don't worry. Those who are not done, you have 2 more minutes. Slowly first. We will wait for you. All right. We have 3 students submitted the answer already. Well done. The remaining you can you have now 1 minute and a half left. Let's see your progress currently. We have pH neutral. Okay. Actually, something is wrong. No worries. Let's go through the letter. Then we have Ant is doing the thing now. So far, so good. Neutral, acid, base, acid, base. Water is not a base. All right, Ant, take note. Water is not a base. Water is neutral. right, let's carry on to show you the answer now. Okay, as mentioned just now, pH 7 is neutral. When you see the pH paper, litmus paper turns red, it means it's acid. When you see the name containing hydroxide, it is base. All right. When you see a chemical equation having a H symbol, it is acid. pH 8 to 14 is base. Water is definitely neutral. Turning litmus paper purple is base. When you see the symbol having OH, it is base. When you see a pH value less than 7, it's always acid. All right. For those who just came in, you can join the Nearpod sessions via the link I sent in the chat. All right. Let's carry on. Then we have coffee. Coffee, is coffee acid or base? Does coffee taste slippery? Or is coffee blunt or what? Well, the answer is coffee is acid. All right, the pH value of around 5 or 6. All right. Hydrobromic acid, when you see the name is acid, is acid. Then we have bleach is base, because all those cleaning products are all base. Do you get the answer correct? All right. I will screenshot this and I will send in the group chat later on. All right. Let's carry on with the lesson. I hope you understand. All right. Next slide. On the next slide, you'll watch a video on how water can create hydronium ions. As you watch, right, please pay attention to how the hydronium ions forms, as well as how the pH scale was named. All right. Sit back and enjoy.
Hi, it's Mr. Anderson, and in this video I'm going to talk about acids, bases, and pH. If you ask people what pH measures, they'll usually say if something is an acid or a base. And they might know that water has a pH of 7, that acids are generally lower than that, and bases higher than 7, but that's where a lot of people's understanding ends. And so I kind of want to explain to you what pH is and how it's determined. But before that, I want to tell you why it's important. I'm a biology teacher, and so everything kind of goes back to life. And so this is a protein, it's called myoglobin. It's found in your muscles, and it's going to be most active at a pH of 6. It's going to work at a pH of 5 all the way up to 7, but if we start to move our pH too low or too high, that protein's going to denature and our muscles aren't going to work. And so it's important that the pH levels remain relatively constant and they're not changing that much. But what is pH? Well, we've got to start by talking about water. And so this is a water molecule. Remember, we're going to have hydrogen here, 2 hydrogen atoms, and then 1 oxygen atom. Now, one thing that you need to understand is that this is a polar molecule. And what that means is there's a covalent bond between the hydrogen and the oxygen, and between this hydrogen and oxygen as well. And oxygen is really greedy when it comes to electrons. It's going to pull the electrons towards it. And so this is a sharing of electron between these atoms, but it's a polar covalent bond. And what that means is since oxygen's pulling the electrons towards it, it's going to have partial negative charge on this side of the oxygen, and then hydrogens are going to have a positive charge on the other side. And so if we were to add another molecule of water, these are not going to arrange this way. And in fact, what we'll have is that they'll be arranged like that. And so the hydrogen atom of one water molecule is going to be attracted to the oxygen of another. And that bond is called a hydrogen bond. A lot of students think that hydrogen bond is in here. No, that's covalent, but the hydrogen bond is going to be between the positive hydrogen, partially positive, and the negative oxygen. And that's why if we have one water molecule and the hydrogens are like positive and the oxygens are negative, and we have another one, they're going to line up like this. And as I pull one water molecule, the other one is going to go along with it. And that's why we have cohesion, and it explains a lot about water. But some weird thing happens with water. Sometimes that attraction is so great that this hydrogen atom will actually become detached from the water, and it'll become attached onto this other water molecule. That would be like me pulling this pinky off and attaching it over onto this other water molecule, leaving me just with this. And so what is that called? This is called hydronium. Hydronium is going to be H3O, and it's going to have a positive charge. What are we left with over here? This is a hydroxide ion. And so what is pH a measure of? Well, the P stands, we think, for the power of hydrogen. In other words, the amount of hydrogen. But it could also be the amount of hydronium or the amount of just free hydrogen ion inside the water. And so if we look at the power of that, or almost the percentage of that, that's going to be what pH measures. And in regular water, distilled water, the amount of this occurring is really, really rare. In other words, it's a 1 in 10 million chance that we're going to have.
All right, so now you understand roughly a little picture on how hydronium ion was formed. It's basically due to the negative and positive charges that attract to each other, whereby one water molecule basically pulls the other hydrogen from another molecule and make it into H3O instead of H2O. In my next slide now, please draw and tell me how hydronium ion is formed. All right, so students, I hope you are paying attention to the video just now, because the video did tell you how hydronium ion is formed. All right, you have 5 minutes. All right, so draw how the two water molecules becomes a hydronium ion. All right, so the hydronium ion, right, actually, right, have this function whereby water molecule is H2O, but however, for hydronium ion is H3O. So as long as there's a presence of acids in the solutions, the acid will dislocate to form hydrogen ions and combine water molecules to form hydronium ion. All right, this can be applied to any water. As long as you're giving a drop of acid in the water, hydronium will be formed. So I give you 9 minutes. So as mentioned earlier in the video, a hydronium ion is a water molecule that is a product of the interaction between hydrogens and oxygen atoms. All right. So it basically means it gains extra positive hydrogen ion from another molecules. All right. As the basic chemistry mentioned to us in the earlier chapter, that all atoms consist of 3 things: electrons, which give a negative charge; protons, it give a positive charge; neutron, give a neutral charge. And all these things will give a H3O because of all these charges. All right. So a water molecules, also written as HOH or H2O, can become unstable over time. And when it does, one hydrogen atom separate from the HOH combination to form H+. And sometimes if another molecules like hydrogen chloride, HCl, is dissolved in water, the hydrogen will dislocate as H+. Then this H+ will attract to the negative poles on another water molecules. This leaves an H2O with an extra atom, which given become H3O. And if a solution has many hydronium ions, this water from pH 7 neutral becomes acidic. the concentrations of the hydronium ions is directly related to the pH value. All right. If there's many hydronium ion, the solution or substance becomes more acidic. All right. So let me see what you're drawing now. Remember, I mentioned just now, two water molecules, one of the water molecules, hydrogen will be attracted to another molecules to form three hydrogen and one oxygen. Let's see your image now. All right, we have I see supreme one. So basically, back to this thing. So what happened is this one will be attracted to here. All right. Hence, giving this a newly formed oxygen that's attracted to one. All right. Two. And three. What happened to the other oxygen here? It basically leaves with only one left. All right. So this is what this is. This is the end product. All right. I hope you get your answer correct. All right. Let me see your drawing now. Yes, we have Alice. Well done. We have James in progress. Okay. Then we have Luna. Okay. All right. Shall I move on? Okay, let's move on to the next question. How did the pH scales get its name from? In the video, we have talked about the person in the video mentioned something about pH scale getting its name. So how does pH scale get its name from? Let's see your answers. Do you still remember what is the full name of pH and why is it called pH? Well, the answer is basically pH stands for power of hydrogen. All right. So the term pH, students, was first described by scientists in 1909. And pH is known as power of hydrogen, where the P is a short form for a German word known as power or potence. All right. Not sure that I pronounced correctly. The German word for power is this one. All right. Then we talk about H is the symbol of hydrogens. All right. So this is how this pH name came about. It's basically telling you how much power of hydrogen this particular substance have. Hence, therefore, pH is now being measured to see how acidic or how alkaline this particular solution is. All right. And it's based on the number of hydrogen ion concentration in the particular solution. All right. So let's see, you guys get correct. Okay, so very well done. Well done, very good. All right, so let's carry on then. So don't remember that what is pH? pH stands for power of hydrogen to test whether how much or how less concentration of hydrogen ion is present in the solution. Okay, let's carry on. Okay, on the next slide, you will be watching a video on how the pH scales is based on the concentration. Concentration means, right, how packed, how much or how less this particular substance have in the particular solution. as you watch the video, do try to check whether the particular substance is a acid or a base, depending on the concentration level shown in the video. All right. With that, I'm going to move to the next video now. Sit back and enjoy.
Hi, it's Mr. Anderson, and in this video I'm going to talk about acids, bases, and pH. If you ask people what pH measures, they'll usually say if something is an acid or a base. And they might know that water has a pH of 7, that acids are generally lower than that, and bases higher than 7, but that's where a lot of people's understanding ends. And so I kind of want to explain to you what pH is and how it's determined. But before that, I want to tell you why it's important. I'm a biology teacher, and so everything kind of goes back to life. And so this is a protein, it's called myoglobin. It's found in your muscles, and it's going to be most active at a pH of 6. It's going to work at a pH of 5 all the way up to 7, but if we start to move our pH too low or too high, that protein's going to denature and our muscles aren't going to work. And so it's important that the pH levels remain relatively constant and they're not changing that much. But what is pH? Well, we've got to start by talking about water. And so this is a water molecule. Remember, we're going to have hydrogen negative and we have an H3O and it's going to have a positive charge. What are we left with over here? This is a hydroxide ion. And so what is pH a measure of? Well, the pH.
Well, so since it's the same video, I think I misplaced the link. So based on the video that you saw just now, what is the relationship between the pH scales and concentration? All right, please let me know in the open-ended below. You know that pH scale is used to measure something. So what is the relationship between the pH scale and the concentration of the hydrogen ions? So we know that hydrogen ion, right, are basically positive charged ions, and that forms when hydrogen lost an electron to another substance. Because hydrogen atoms have 1 electron and 1 proton, hydrogen ions are simply just a proton. So the answer to this question is, right, the pH of a solution is a measure of the hydrogen ion concentration. Basically, it means that, right, if a pH refers to a negative base of 10, it means to say that, right, it do not have much hydrogen present in the substance. So lower pH value corresponds to the higher concentration of hydrogens, whereas higher pH value correspond to a lower hydrogen ion. So to answer this question, basically we need to say the relationship between pH scales and concentration are, number 1, the lower the pH scale values get, the higher concentration of hydrogen ions found in the solution or substance. Whereas the higher the pH scale value get, the lower concentration of hydrogen ions found in the solution or substance, which is known as base. This is known as acid. All right. So far clear? Now, we have acid on this side. We have base on this side. How do I make it neutral? There could be some way or somehow, right? I can make an acid become a base. I can make a base become an acid, or I can make them become neutral. So how do we go about that? Well, when an acid and a base react with each other, this is called neutralizations. And these neutralizations reactions will happen when you bring one acid and a base together. And the result of this neutralization, water is formed. Take a look example at this chemical equation here. We have hydrochloric acid that's mixed with sodium hydroxide. So we have HCl plus NaOH give us water and sodium chloride. Why? Because the hydrogens ion here will react with the hydroxide here, thus forming H2O water, whereas the positive sodium Na here will react with the negative chloride here to form sodium chloride. All right. So in this reaction, the positive from the hydrochloric acid will switch with the sodium positive, and in this double reaction to form water and salt. So in this case, the salt is known as sodium chloride. So a generic formula for everyone to understand and remember is acid plus base equals to water plus salt. This equation will never change, no matter how you do it. When you add an acid and an alkaline base, you will get a water and salt. All right. Now, students, you look at this now. Tell me which one is base, which one is acid, which one water, which one is salt. Remember, I mentioned just now earlier, base will always end with OH. Acid will always have a H. Water is standard H2O, and the product form is salt. So you have around 2 minutes to tell me which one is base, which one is acid, which one is water, which one is salt. Like I mentioned, the purpose of this lesson today is for you to identify which is acid, which is base, and how do we neutralize them, and how does it interact with the environment that we're living now. So in order to do that, you have to first learn how to see if this particular substance is acid or base. So I saw Supreme submitted already. Well done. All right. Then I saw this submitted also, Luna submitted also. All right. Remember the difference between the acid and the base. All right. We have the acid that is always containing hydrogen H no matter where they go. Base always have OH, which is hydroxide. And when you react acid and base, acid plus base will always give you water plus salt. And water, we know the standard is basically H2O. There's no way to change the formula for water. All right, we'll give you all another 1 minute to do up this thing. So as long as you see the word OH or hydroxide, it is a base. You see a word acid or H in the chemical symbol is called acid. Water, H2O, and acid plus base equals to water plus salt. All right. Okay, let's carry on there. Let's see the correct answer. So KOH, based on what we have learned, when you see the word OH, it means it is a base. All right. Next up, H2SO4. When I see the word H, it is acid. I know that acid plus base or base plus acid will give me the product of water plus salt. And I know water is always standardized as H2O. We have the remaining as salt. So therefore, with all these things in mind, we have base plus acid plus, base plus acid equals to water plus salt. I hope you guys know the equation now, because I'm going to give you a short quiz now to everyone here. All right. Now, in your nearpod now, there is this short quiz of 5 questions. Answer them, and let's see how much you know. All right. All right, we have Luna getting correct. Very well done. So, yeah. So, true or false? Let's see. We have question 1 as true or false. The hydronium ion is classified as a base. Is it true or false? Then we have the second question is the color representing pH 7. Do you still remember the color of the pH 7? Then we have lithium hydroxide is a what? Is it acid, base, or neutral? Then we have sorry, acid and base together. It forms what? Lastly, which of the following is a acid? All right, so these 5 questions, I'm going to give you 1 minute or 2 minutes or so to do for me. All right, to test whether how much knowledge you know about this. All right. So your 2 minutes starts now. Remember, when the equation have a lot of H, it means to say that it is acid. All right. In 1 minute time, I'm going to go through the answers. Sorry. All right, let's see the answer now. Let's see some of you. All right, we have James. We have this Ren, is it, or Hui? We have Supreme. We have Luna, and we have Lind. Okay, let's go together. True or false? The hydronium ion is classified as a base. The answer is false. Why? Because there's a presence of hydrogen's ions. Therefore, the answer is B. All right. Next questions. Hey, sorry, my bad. How do I go next question on my side? Okay, a moment. So it's space. Okay, next question. The color represent pH 7. So which color actually represent pH 7 in the litmus paper? All right. We have the option of red, purple, orange, and green. All right. We know that red is strong acid. Purple is alkaline. Then we have of this, we have green as pH 7. All right, which is neutral. Next up, lithium hydroxide. We learned today that as long as the name, sorry, as long as the name have the word hydroxide, is classified as a base. All right, if the name have the acid, is classified as a acid. All right, next question. When an acid and a base react together, what is formed? Based on our activity we did just now, acid plus base give you water and salt, right? And also we know that water is actually a neutral compound, right? So technically speaking, right? So how? Is it water or salt? Did anyone get correct based on answer? Yes, Supreme got it correct. Well done. Because water is a neutral compound, that's why the product form is water and salt. So as all above. All right, next up. Which of the following is an acid? We know that acid is something to do with hydrogens. And then we know that blood is a bit alkaline. Baking soda obviously a bit alkaline. So answer should be somewhere near to the water side. All right. So battery, is battery alkaline or acid? Based on what we know, battery is alkaline, right? Is battery alkaline or acid? Anyone know the answer? All right. For battery is alkaline, and then for blood is alkaline, baking soda is alkaline. The only answer is milk. Milk is a bit acid. All right. So with that, I'll end the session for today. All right. So I will see you all next week for not next week. Sorry, I'll see you all in 2 weeks time for the final lesson of Rhythm Science. It's been a great 1 year. Teaching and learning with you all. Just that my current work schedule in school is unable to support this Thursday session. So I will wrap up the entire series in 2 weeks time on the 24th of November, if I'm not wrong. So I'll see you all for the last.
Goodbye, teacher.
Goodbye. So I will see you all.
Goodbye, teacher.
Bye bye. Take care.
See you. See
Bye
you.
bye.
Bye.
Bye bye. Take care.
For your lesson.
Yeah.
Goodbye. Lesson sounds
Bye.
great.
Take care.
So maybe next week, Alice, we do revision, yeah?
Yeah. So next week I can't attend due to the graduation ceremony, but the following week 24th will be a last session.
Yeah.
Thank you very much.
So Alice will run the class next week. Do the quiz like normal.
All right. Thank you very much. Thank you. Bye bye.
Thank you.
Thank you, Andrew. Bye. Bye Alice nha con.
Chào cô.
Vậy tuần sau Alice làm ha.
Chào cô. Hồi nãy
Cô chào các bạn nha.
cô hồi nãy hôm qua hôm nay con nói là thầy Phụng ở trong lớp trình là em trai của con Nga Hạ của Đức.
Hả?
Hồi nãy thầy Phụng là em trai của cô Nga hả? Hồi nãy mẹ con nói đấy.
Cô không biết.
Ok.
Rồi,
Con Nga
bye
hay
bye
tiếng
em.
Anh đấy cô. Con Nga hay dạy tiếng Anh đấy cô.
À vậy hả? Cô không biết. Bye em.
Bye.